Going to be our last video for Unit 1. We'll look at linear inequalities and absolute value inequalities and follow that by rational equations. So these two sections are pretty short, but it's some pretty heavy material. Alright, so solving as a warm-up, we'll solve some inequalities, which I'm sure that you've done. So the key with inequalities is to remember if you multiply or divide by a negative, you need to flip the sign. Okay. So what I would do here in this first one is subtract the 2x and add the 3 to both sides. Oh, no, sorry. Subtract the 2x and subtract the 7, because we want the variable on one side and the number on the other. So that'll be 2x is greater than or equal to negative 10. And then divide by 2, we get x is greater than or equal to negative 5. And it wants interval notation, so we want greater than or equal to negative 5. So negative 5 will be the smallest number, and then it'll go to infinity. Parentheses always goes around infinity. If there's a equal sign or like a line underneath the inequality symbol, then you want a bracket there. Otherwise, you would do another parenthesis. Okay, this other one, kind of do the same thing. I'll subtract 10x on both sides so that my x's are on the left, and then subtract 13 on both sides. So we get negative 17x is greater than or equal to negative 17. Divide both sides by negative 17, but remember that you need to flip the inequality so that we get, oh, that's interesting. I see what happened. Never mind. I won't go into it. There's nothing wrong with this problem. I just did something silly before. So x is less than or equal to 1, so that means 1 is your biggest number here. And since that line is underneath there, you want a bracket. And then the smallest number is infinity. So it'll be parentheses negative infinity to 1. On the next page is an explanation of all the interval notations. Compound inequalities, I never separate it. I think that's way too confusing. I would use this method, but if you guys like that one, then go ahead. Because the compound, you know, it's not that, it's just more straightforward. Whatever you're doing to the middle, you do to the two ends. Like if I subtract 2 in the middle, I gotta subtract 2 everywhere. So I get 1 is less than or equal to 2x less than 4. And then I want to divide by 2 to get x by itself, so I divide by 2 everywhere. And I get 1/2 is less than or equal to x is less than 2. And then interval notation actually with this is kind of easier because you just put one number on one end and one on the other. Keep in mind that if it's got the, oops, I meant to do highlighter there. If it's got the line underneath, then you need a bracket. See, this side doesn't have a line, so I did parentheses. Okay. So here's the table that, in our chart that I was talking about. It's not probably something that you want to memorize per se, but just remember that infinities always have parentheses, and if it has the line underneath, then you use bracket. If it doesn't, use parentheses. Now, absolute value inequalities are a little bit harder to comprehend, but this little picture here where we're talking about describe all values of x within a distance of 4 from the number 5. So 5 is in the middle, and then we could go distance 4 to the right or 4 to the left. So what would that describe? Well, 5 minus 4 would be 1. 5 plus 4 would be 9. So that would give you 1 and 9, or the interval from 1 to 9. Algebraically, it would look like this here, where you would solve, and if it's less than, then the absolute value goes, what's in the absolute value goes in between. If it's greater than, then, well, it shows you up here. So the way I remember it is like this is greater, this bottom one. So you make an or, you make 2. But if it's less than, then it's just 1. It's a silly thing, but it helps remember. So this is going to be x minus 5 is less than or equal to 4 or greater than or equal to negative 4. So you take the 4 and you put it on the other end and make it negative. And then we add 5 in the middle, just like we did in that other problem. And we have to add 5 on the ends. So we get 1 is less than or equal to x, less than or equal to 9. And that's just from 1 to 9. So this absolute value of x minus 5 less than or equal to 4 is the algebraic way of writing this. And if that doesn't make sense, then just try to remember these rules. All right. Yeah, we already did that. All right, so that is that homework. Oops, I need to go back. Or not homework, that is that note. So your last set of notes is these rational equations. I hope I'm still recording. Yeah, okay, good. Let me get my pen. And I think we missed a page. There we go. All right, so there's a warm-up of factoring. So x squared minus 36 is the difference of 2 squares. So it's x plus 6, x minus 6. Solve for y. Okay, well, we need to subtract 5x on both sides. So that's 2y is equal to negative 5x plus 10. Then divide by 2. So y is equal to negative 5/2 x plus 5. Adding fractions, we'll do it by hand just because that'll help us a little bit more with the section. So the least common denominator of 3 and 5 is 15, so I have to multiply by 5 over 5 and 3 over 3. And I get 5 over 15 plus 6 over 15 is equal to 11 over 15. It's important to know that for this section because you'll be doing the same thing but with like variables, so the calculator can't actually do it. So a rational equation is an equation that contains a rational expression. So let's look at the example down at the bottom. 1 over x plus 1/3 is equal to 5/6. So you do the same thing as you would do with like solving, well, never mind. What you're going to do, I guess there's nothing really like this. It's similar to adding, subtracting fractions, if you remember that stuff. But you want the LCD of 3, 6, and x. So you want a number that all three of those can be divided into, and that would be 6x. Why? Because 6 can go into 6x, 3 can go into 6x, and x can go into 6x. Would 12x also work? Or 24x squared? Sure, but this is the lowest one. So you multiply both sides of the equation by 6x, and so that's, distributing, and that reduces down to 6 plus 2x, and you'll notice that after you multiply by the LCD, the fraction's gone, and you just have a regular, easy linear equation to solve. So this breaks down to 3x equals 6, and we get that x is equal to 2. just go back in and look at the original equation and make sure that you can put 2 in for x, because x cannot, the denominators cannot be 0. Okay, so here's another worked through example. It gets a little tougher. We have negative 4x over x minus 1 plus 4 over x plus 1 equals negative 8 over x squared minus 1. And we just take a note. That's why we looked at the domain earlier. We can't put negative 1 or 1 into any of these because that would make the denominator 0. So first thing you want to do is factor anything that can be factored. And x squared minus 1 can be factored to x minus 1 and x plus 1. And this one's kind of easy because the factors of x squared minus 1 are, oops, I keep clicking the wrong thing, are right here. So then you just want to multiply both sides of the equation by the LCD. And the LCD is just x minus 1, x plus 1 because all three of these can go into it. And what happens is the x minus 1 on the bottom will cross out with the x minus 1 on the top. The x plus 1s cross out, and then this whole thing crosses out, and it comes out to be, again, a quadratic equation this time. But with the fractions gone, it's just a whole lot easier to tackle. So we can go ahead and finish this. If I distribute the minus 4x to the x and to the 1, I get negative 4x squared minus 4x. Distribute this one through, gets 4 plus 4x minus 4 equals negative 8. The minus 4x and the plus 4x are 0. So I have minus 4x squared minus 4 equals negative 8. And there's different ways you can do this. Guess I'll just add 4 to both sides. So I get negative 4x squared equals negative 4. Divide both sides by negative 4, so x squared equals 1. That would give you the solutions plus and minus 1. However, you can't put plus or minus 1 into this equation because it makes the denominator 0. So this has no solution. And that happens quite often with rational equations. And then the last thing here is solving a rational equations for a specific variable. So it's kind of the same process where the LCD is easy because there's only one fraction component. So multiply both sides by that, distribute. So we get xm minus 3m equals y minus 2. And we're trying to solve for y, so we want to add that 2 over, and voila, we have y solved for. So I know that, I'll go back. I know that we could do a lot more examples with these rational equations. And if you don't get it yet, that's okay. Just make sure that you write down your questions and